I'm now going to do logistic regression. I'll go Analyze, and then Regression, and then over to Binary Logistic. Click on Binary Logistic, open that up. Now my dependent variable has to be bivariate in nature, high, low, pass, fail. In this case, I've got low and high as far as exercise categories. I created these from the continuous variable based on the number of minutes exercised each week. If a person was under 120 minutes per week, they were classified as low. If they were 120 minutes or higher, they were classified as high. So I created that variable. So I'm going to plug that in, binary exercise. That's my dependent variable. Now for covariates, I am going to use FP1. Let's see if we can find that. Here we go. Lack of awareness of appropriate facilities. That seems like it might be something that might impact whether a person is high or low in terms of exercise. And FP5, do not like to work out around other people. Might as well throw that one in. Seems like it could have an impact. I'm also going to use another one that we created after doing some factor analysis, and that was level of enjoyment. So we're going to throw that one in. And I'm also going to throw in gender to see if that has an impact in terms of whether a person is high or low in terms of exercise. So we'll put that one in. Now gender is a categorical variable, and we need to recognize it as such. So I'm going to click on categorical up here, and I'm going to put gender in as a categorical variable. Hit continue. So categorical, in other words, this is a nominal variable. FP1 is a rating, FP5 was a rating, enjoyment was a scale, but it ranges from 1 to 5. So that's also a continuous variable. So I've got this set up. You can see that just like with linear regression, there are different ways of actually creating the model. I'm just going to use enter. So it'll put all of the items we want into the model. And now that I've got the categorical variable set up, all my covariates in place, my dependent variable right up there, I'm ready to hit OK. And we get the output. Let me expand that. And the first thing you'll get is a beginning block. And this is the estimate based on just having the intercept in place. And we can see that this actually predicts 73.8% of the cases correctly, just with the coefficient. But the block 0 is the beginning block. Then when we look at block 1, this is the enter method that we're using, and it will enter all of the variables into the model. And we can see that when those variables are entered into the model, we predict correctly 83.2% of the time. And if we look here at the variables, the Wald statistic, like a t statistic or f statistic or chi-square, is a value. In this case, we can look at the Wald statistic and the degrees of freedom, but what we're really going to look at is the significance down here. And of course, we're looking for a significance of lower than 0.05 if it's going to be significant at conventional levels. So we can see that FP1 is significant. That's obviously much lower than 0.05. FP5 is also significant at 0.046, squeaking in just under the 0.05, but still significant. Enjoyment, significant. Gender is not significant, and the constant is significant. Now, the R-square, these are called pseudo R-squares. They're not true R-squares. They try to do the same sort of thing. They do range from 0 to 1, and higher is better. And then you can go to the PowerPoint slides and take a look at the annotations there in terms of what some of the different variables here mean and how you would use these different coefficients to actually interpret what would happen in terms of market share, or in this case, whether or not somebody would be classified into the higher category. In other words, what would happen if we increased FP1 by one scale number from a 3 to a 4, from a 4 to a 5, what impact might that have in terms of the likelihood that a person would move from the low exercise category to the high exercise category? Recall FP1 was familiarity with the facilities. So you can imagine that as you increase that variable, the likelihood of going from a low exercise category to a high exercise category will increase. The significant value here suggests that that's the case. The question would be, how much of an increase would that wind up being? And that's the kind of thing that logistic regression can help answer.